All right, you have your homework out, and tables 1.1 and 1.2, check those. Make sure you're studying over those. Let's review some things that we talked about in our last lesson. We said physics is just one branch of science. What specifically does physics study? Audrey?
Matter and energy.
The interaction between matter and energy. Good. We said there's two major branches of physics, and we had the classical physics and the modern physics. Really kind of the cutoff between those two was about what year, Kendall?
1900.
About 1900. Do you remember any of the 5 major topics of classical physics that we're going to focus on in this class?
Electromagnetism.
Electromagnetism's one.
Light.
Light?
Gravity.
That's kind of included in one of the other things.
Speed.
Kind of included in one of the other things. All right, you got a couple of them. Audrey, help him with a couple more.
Thermodynamics.
Thermodynamics. All right, Kendall, do you have any more? Sound and mechanics. Mechanics is anything to do with forces and movement. Speed would be in there, gravity would be in there. All right, good. All right, and then the classical, the modern physics, more the cutting edge stuff, the theoretical stuff. We said one of the reasons that we study physics, of course, is to better ourselves, right? To find ways to make improvements and have a good, happy life. Using a Mevo camera, we have YouTube, we have internet, all because people studied science and figured stuff out that was really cool. You guys don't know what it's like to not have internet. I don't feel old, but like I predate the internet. I was alive without it. I remember the days before internet. And anyway, things your parents talk about. Anyway, all right. But another reason we study physics, we said, is so we can see the handiwork of God. And we said God does reveal himself to man through his creation. We call this?
Special revelation.
The other one? General revelation. What is God's special revelation?
The Bible.
The Bible that actually tells us, the Word of God that really tells us specifically who he is. But just general revelation is enough to tell us there is a God. We said that the scientific method, as we looked at that, really been kind of break it down into 3 major subsets or levels of scientific thinking, if you will. On the one level is just deep thought based on your own reasoning, based on your own knowledge, your own experiences. What was that cool word to talk about deep thinking? Cogitation. And so, Lana walks into your room and is like, Audrey, what's the matter? Nothing, I'm just cogitating. I need some time alone to cogitate. Mom, I think she's sick, whatever. But cogitation. And of course, that would involve thinking about, wonder why. I wonder what would happen if. That's the thinking level where you're posing the question. You're perhaps positing a hypothesis. I bet it's because of this. That would also include, I would say, deep thinking could also include the research side of things, where you're trying to figure out, has this already been answered? Siri, blah, 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 or Alexa, or just Google if you're like me. And then it kind of tied in with that would be doing some further noticing of what you see around you. We could call this? Before that. Observation. Just noticing what's going on around you. Probably there's been some observation for you to even have a question, right? But maybe further observation. But that's not sufficient, right? It's a good starting point to a scientific question, but we really have to get into... You were just ahead of your time. That's all experimentation, right? And of course, it'd have to be carefully designed to make sure there's only one variable. Everything else is kept constant. A control group would be ideal, if possible. Usually it is. But as we're doing the experiment, we come to a conclusion. We do it over and over again until we come to a conclusion. This is why this is, or this is what would happen if. And we get our answer to our scientific question. Of course, we share it with the world, and we get all the credit. And it's great. And you don't get any money out of it, but you get credit. In some cases. Or other scientists pick it apart and find holes in your experiment, which is actually what happens most of the time, but that's all part of scientific progress. Is you put it out there knowing people are probably going to find holes, mistakes, that's okay, because it's all in the interest of gaining better scientific knowledge. You just can't be really sensitive. We said as you're keeping track of everything, Lord Kelvin it was who said, unless you can express something in numbers or mathematics, you don't really understand it. So we have to have numbers, we have to have measurements or recorded data for all of our experiments. And as we record data, there's a couple different sets of units we can use. We said scientists use a set of units called SI, System International, the SI units. And then the other system that stubborn people around the world who are resistant to change will use? Kendall? They're not really around the world much. It's us and Liberia. The U.S. customary units. And U.S. customary units based on feet for length, pounds for weight or mass, technically weight, but anyway, and then time would be measured in seconds as the base unit. But in SI, there are 7 fundamental quantities, fundamental units we need to know. The length should be pretty easy.
Meter.
The meter, okay, it's pretty easy if you look, okay. The meter. Time is still the second, just like in the U.S. Mass, though, is in kilograms. That's why we call it MKS. Okay, we talked about where those standards, how those standards are defined now. Then there were some others that aren't included in the MKS. Those are the most commonly used, but we said, for instance, the amount of a substance, class we would have the mole, okay. If we wanted to measure temperature, Kelvin. If we wanted to measure electrical current, ampere or amp. And then if we wanted to measure luminous intensity, candela. So those are your S7, SI fundamental units. Make sure you know those. And we said we can derive larger or smaller units off of those depending on some metric prefixes. Without looking at your homework or in the book, give me one of our metric prefixes we need to know and use this year. Kendall? Mega, all right. And mega literally means millions. What is the E value associated with mega? E6. Think of a million has 6 zeros in it. Okay, so there's your E6. And what is the symbol for mega? A capital M tells me we've got mega or E6. Another one. Centi. And what is centi? Close? E-2. And think of centi as like a cent is 100th of a dollar. Okay, so 100th, which is 2 decimal places. Decimal places would have negative, but there's your 2 decimal places. And the abbreviation for centi? C. Another one, Audrey. Deca. Well, that's not one we'll really use in this class. It is one, but it's not one we'll use in this class. Milli is one that we'll use in this class. And I think of millennium as 1,000 years, but milli doesn't mean 1,000. It actually means 1,000th, right? It's a piece of 1,000, if you will. So thousandths is 3 decimal places. So my E value, E-3, and the abbreviation for milli, little m. And Kendall, give me another one. Kilo. And kilo literally means 1,000. What's the E value? E3. Again, for bigger values, we go off the number of zeros in the number if you want to remember it that way. 3 zeros in 1,000. What's the abbreviation? Little k. And okay, little k and little m. Anyway, should have thought of that last year for the door. So we got a couple more that are smaller ones. So we got a couple for larger units. We got a couple for small units. Then we got some for really small units. Michael? Micro would be the next small one, and that is E-6. It means millionths, and we're out of M's. So do you remember what we used?
It's a weird U.
It's a weird looking U, or it's a weird, if you put the little hook on the front and look at it saying it's a weird looking M, it's actually the Greek letter mu, okay, like the sound a cat makes. You have cats, right? Do you have cat? Yeah. Okay. You have cat. All of you have cat. Mu. All right. And then the last one, billions, even smaller. Anyone? Nano. And that's going to be E-9. Notice they're all multiples of 3 except centi. Right? All the rest of them are multiples of 3 here. And nano class is N. And there we go. Questions on those? All right. Well, let's get into some more, kind of built on this idea of these E values. Let's talk about scientific notation. Next thing in your notes. Scientific notation, something we talked about, well, lots actually. We taught 8th grade, probably 7th grade, so I just don't teach 7th grade, but I know 8th grade you did, 9th grade, we touched on it. 10th grade, I don't remember. 11th grade didn't use it a whole lot, maybe some practice exercises, but scientific notation, you probably used it in past science classes. It's just a way of writing big numbers more quickly. The idea is to get out of writing a bunch of zeros, all right? So 93 million. What's significant about the number 93 million?
Miles from the sun.
Approximate miles or average miles of the Earth from the sun. Remember when writing in scientific notation, it's all about the movement of the decimal. Right now in the number 93 million, where is my decimal class? At the end. But in scientific notation, remember, you can only have one digit before the decimal. So I'm going to have to move the decimal so it goes right after the 9. So my number becomes 9 point, and you're going to write all the non-zero digits, or if there's 0 digits in the middle. For instance, if this had been an 8. Okay, I have to keep writing until I get to straight zeros. Well, I don't have to write very far. I'm already to straight zeros. So you can stop writing when you hit straight zeros. And then we're going to say E, and we're just going to count how many places the decimal moved. How many total places did the decimal move, class? 7. So we get 9.3E7. Do we remember this from past classes? All right. If I had a small number, though, 0.0000000247, for instance. Well, it's a small number, a teeny tiny number, okay? And so I'm going to have to move the decimal the other direction, but I'm still going to go so that there's one digit before the decimal. So I'm going to move the decimal class after the 2. So this becomes 2.47. And with decimals, you generally don't hit a string of zeros at the end because we just don't write them. So 2.47, again, we're going to put our E. Notice it's capitalized, but it's shrunk, okay? And we're going to count how many places the decimal moved again. 1, 2, 3, 4, 5, 6, 7, 8, but it went backward. So E negative 8. You remember this from past classes. All right, you get a chance to practice this in just a moment. We did want to show it again, though, since it's been, at least a summertime since you've seen this, probably longer. Questions? Occasionally, we will have a reason to expand scientific notation into a regular number just for our own reference. For instance, if we had something like 9.48 E negative 2. Well, we don't think in terms of scientific notation that often, so it may be helpful in some cases to see the number just in its normal decimal form. In this case, when I see a negative E value, I'm thinking little number as opposed to big number. Well, if I move the decimal this way, that's going to give me a bigger number, right? So I'm not going to move it that way. I'm going to move it this way. You can memorize the right-left rule if you want to. I just think practically. Negative means itty-bitty. I got to go this way to get itty-bitty. 2 places. 1, 2. So I'm going to get 0.0948. Do you remember seeing this side of scientific notation? All right, again, all this should be reviewed for you. And 1.387 E5. Well, this is a positive E value, right? So that means a big number. So which way does the decimal go? That way to the right, correct? So 5 places. Now the first 3 places already have digits. That leaves 2 more digits I'm going to have to turn into zeros. I'm going to add a couple zeros. So 1, 3, 8, 7, 2 more. We'll make both of them zeros and insert our comma. So now we can see that this number means 138,700. Questions on scientific notation. Again, if this is not review for you, we would do more practice with it, but I feel like we should know this. Practice in your books here for just a moment. Page 17. Problems 1 and 2 all. If you're watching on YouTube and you're like, I don't remember any of this, send me an email and I will send you a link to one of my earlier videos in another class where we spend more time working on this. By the way, do you notice on page 17, you see there's questions at the top, problems at the bottom. We're doing the problems at the bottom. But when you copy homework assignments moving forward, make sure you carefully copy down problems or questions so you don't get the wrong assignment. Just a quick word of admonition there. second hand doesn't work. That's a bummer. All right, let's take a look at our answers here. Page 17, problem number 1. You're writing these numbers using scientific notation. Letter A, they gave you an 86,400. What's the significance of that number? I actually mentioned it yesterday. Seconds in an average solar day. Okay, so seconds in a day. That's how they used to define the second. Remember, was 1/86,400th of the average solar day. But how would we write that as a scientific notation number? Kendall?
86.483.
Now remember, how many digits are you allowed before the decimal? Only 1. Right, so when you moved it, you put it here, 86.4, but we can't have 2 digits. We gotta go all the way here. So amend your answer.
8.64.
There we go, good. We're not moving past one number, we're moving until there's only one number left. Now, if you're going the other way, to get one number in front, you only have to go past one number. So you're keeping them straight, and that's fine, that's why we practice. How about the next one? 299,790, or 299,790,000, that's approximately the number of meters per second, the speed of light. And what do we get for that? Audrey?
2.9979E8.
Excellent job. And for the next one, 0.000004161 becomes what? Michael?
4.161 E-6.
Excellent. And then the last one, 0.0821, that's actually the value of the universal gas constant. We'll look at that later on in the year. Might have looked at it last year in chemistry. Kendall?
8.21 E-2.
Excellent. Questions on writing in scientific notation? Feel like we got it now that we had a chance to practice. All right? Have the opportunity to mess up and learn from it. That's perfectly fine. That's why we do it. All right, number 2, you're changing these numbers back into decimal notation. 7.03E5 becomes what, Michael?
703,000.
Great job. How about 3.41E-3, Audrey?
0.00341.
Good. Letter C. 2.385E3 becomes, Kendall?
2,385.
I think that number looks a whole lot better in decimal notation, don't you? Not a whole lot of benefit to the scientific notation on that number. How about 4.53E-3? Let's stay with Kendall.
0.00453.
Excellent job. Questions on any of those? Anyone go 8 for 8 on numbers 1 and 2? Got them all? All right. And Kendall, was it just the one that you missed?
Yeah.
All right, good. Unless I learned from it, that's perfectly fine. All right, next thing you know is adding or subtracting with scientific notation. Next thing you know is adding and subtracting with scientific notation. Now, I want you to think back to algebra class, and when we added terms, remember I said you can only add like terms together? That is that they had the same letters to them. Like you could add an 8x and a 5x, but you couldn't add an 8x and a 5y. Do you remember that? And I said if you added an 8x and a 5x, you just added the 8 and the 5 to get 13, just kept the x. Similar to how we add scientific notation. Step number 1 for adding or subtracting scientific notation. All right, there's my shorthand. Geometry lives strong. Step number 1, first key thing, you must have the same e values. You must have the same e values. It's like them being like terms. An E5 can be added to another E5. An E-4 can be added to another E-4. But an E3 and an E2, you can't add or subtract them. Does that make sense? They have to have the same E value. So, if they're not the same E, we're going to make them match. We're going to make them match. And strategically, the easiest way is to always make them match the larger E. So make them match the larger E value. We're going to look at some examples here in just a moment so you'll understand it. For now, just write it down. But basically, if we're adding an E5 to an E3, you can't do it. So force the E3 to become an E5 is basically what we're going to do. Once we've done that, then add or subtract. Pretty easy. And, like before, keep the same, which means the larger, because that's what we changed to, E value. The e's themselves don't get added or subtracted. Just like 3x and 5x isn't 8xx, it's just 8x. We just keep the x. So when we add an e5 to an e5, we get an e5. Now, what do we mean when I say make them match the larger e? Well, we're going to have to move the decimal around a little bit. For instance, let me show you this. If we had a 7.2 e4, this literally means 72000 or 72,000, correct? But what if I needed it to become an e6, for instance? Well, an e6 means the decimal moves 6 places, right? 1, 2, 3, 4, 5, 6 would be 0.072 e6. Now, this is not properly written scientific notation, but all we care about is that our answer is proper. We don't care that the process to get there is necessarily proper. So these mean the same thing. Does that make sense? But we don't want to take time to expand it out and put it back. So here's the basic idea. In order for an e to go up, the decimal is going to have to shift to the left. Do we see it? The decimal went left as the e went up. But let's suppose, I don't know that we would want to do this because we're changing to the larger e, but just for sake of showing it, let's suppose I only wanted an e2. Well, e2 means I'd only move the decimal this far. That would be 720 e2. Notice if the e goes down, the decimal has to shift to the right. You see that? So rather than taking time to write the expanded form, I'm going to have you memorize a couple rules. We'll just put it on the little chart. Okay, so as I drop that, let's do e and let's do decimal. The most common use is to make the e go up so the decimal goes left. Occasionally, we'll see a couple of things today where we'll need the e to go down. It's pretty rare, but we may, in which case the decimal goes to the right. So what I like to do is I like to think kind of Southern. I'm not Southern. I like to think Southern for this, okay? So if Kendall is, maybe Kendall has this worthless bum boyfriend that her dad doesn't like. She doesn't really, for the record, okay? But she has this worthless bum boyfriend that her dad doesn't like, and she and worthless bum boyfriend have an argument, and being the worthless bum that he is, in the middle of the argument, he just storms off and goes away from her. And so Kendall's complaining to Audrey the next day, and what would a good Southerner say? He just up and left me. Up and left. He up and left. Or if it's you sharing your sob story, she up and left, whatever. Also, if you're having a really, really good meal, Kendall goes over to worthless bum's house and mom feeds a meal, and she wants to please the mom of this worthless bum boyfriend that her dad doesn't like, and who she shouldn't be with because her dad doesn't like. But anyway, and the mom fixes a meal, and she wants to be polite, so that was downright good, right? It's something so okay, downright. He up and left. That was downright good. If you don't like my way of remembering, come up with your own, but I like my way of remembering it. So there we go, up and left, down right. That's going to help us move our e and move our decimal along with it. All right, or whatever you come up with, or you just think through it logically because that makes sense too. But I like goofy stuff. All right, so let's take a look at some addition problems here. Jot just this first one down on your paper. I want you to work it along with me here, and let me zoom in just a little bit more right here. First problem's really easy because we already have the same e's, right? They're already both e4s. It could not be easier. You just add 2 plus 6. You add 3 plus 8. You carry the 1. 1 plus 1 plus 5. 7.18, and you just keep the e. Couldn't be easier, right? Because they already had the same e. But look at the next one. They don't have the same e's, do they? So for this problem, I'm going to have to change the little e to become the bigger e. Okay, I know it's discrimination against the little. I'm sorry about that. That's not intentional. It's just how it goes in science sometimes. All right. So we're going to have to bump the E3 class up to an E5. Well, in changing this to be E5, notice the E went up. She up and, Michael, left. Yes, it's the story of your life. Anyway, E up and left. So I'm going to move the decimal to the left 2 places because the E went up 2 places. Make sense? So bump it up 2, I get 0.0832 E5. Do you see how we changed it really easily without having to do any crazy thought? Now, the only thing is when you add these now, you want to keep your decimal lined up. So I'm going to write the 6.9 right here so I keep my decimal. And now it really couldn't be an easier addition problem, because what do we get?
0.9832.
Yeah, and then it's going to be E5. Because again, we just keep the E at the end. We don't add the E values together or anything goofy like that. Questions? Seem pretty easy? All right, at your seats, I want you to do the next one. You've got an E4 and an E3. Let's make them both into E4 by changing the little one, and then add together. Did you make it 0.293 E4? Just move to the left once. And when you added together, should have gotten, Kendall?
7.6.
Ooh.
Wait,
I'll annex a 0 here to make it easier. 3 plus nothing?
oh, 3.
9 plus 5?
14.
And then we'll carry that 1, so not a 6, but a
7.
7. So 7.743
E4.
E4. All right, how many had that answer? All right, question on that? Got it now? Now there is a little weirdness that can happen. Look at the next problem. First of all, you notice the decimals not lined up, but they're both E6s, right? So easy to add. I just want to put the 8.9 here. Obviously nothing plus 1 class. 9 plus 8.
17.
Carry the 1. 1 plus 8 plus 3. 12. Now notice the answer. 12.71 E6. The answer must be written in proper scientific notation. Is that proper? No, because Kendall, we're only allowed to have 1 digit before the decimal, and I've got 2. So I have to move the decimal into the proper place so that it becomes 1.271. But if I move the decimal to the left, he up and left. So I'm going to have to bump the E up to go with it. And my final answer is written as 1.271 E7. Does that make sense? We just bump the E up to go along. Questions on this? All right, let's take a look at some more. At your seats, do the next one. Or the first one on the slide, I should say. And so then we've got it. All right, and Audrey, what'd you get?
7.37.
Michael? 6.37. E-2. Now let's be careful what you're carrying. There's carrying a 1. 1 plus 2 plus 3 gives the 6. All right, now on the next one, which is the bigger E? E-3 or E-4? E-3 is bigger. So that's just a word of caution with negative exponents, or negative E values. I'm going to need to bump this up to a -3. He up and left. So we're going to go to the left to make this a 0.301, E-3. Line up the decimal at your seats, work that one. Michael's got it. The Audrey wants some redemption.
8.641.
There we go. Excellent. At your seats. Let's do this one. No, you can do the next one on your own. Go and do the next one on your own. 6.173 minus 5.083. They're both E3s. That makes it easy. And Kendall. Call when you got it.
1, 8, 0, 0, 9, E3.
There we go. Pretty straightforward, right? Questions on that? And the next one, we're going to have to make them both E5 at your seats. Go and do the last one. And Michael.
6.14.
Good. After we change that to a 0.98 E5. All right, questions on that? I feel like we got a decent handle on adding and subtracting scientific notation. All right. So the next thing in your notes, multiplying and dividing scientific notation. Multiplying and dividing scientific notation. Again, think of terms in algebra. Do you have to have like terms to multiply or divide? No. A 3x and a 2y can multiply. You get 6xy, right? You would multiply the 3 and the 2, and you'd multiply the x and the y, wouldn't you? Or like a 3x and a 2x to the 5th, 6x to the 6th, right? You'd multiply the letters together, and you'd multiply the numbers together. But if they were matching letters, like 3x and 2x to the 5th, you would add the exponents. All right, so for multiplying and dividing scientific notation, let's start with our multiplication rule. Really straightforward. You don't have to have the same e value, but you're going to multiply the numbers, and you're going to add the e values. You're going to multiply the numbers, and you're going to add the e values. Sounds a lot like multiplying terms. Multiply the numbers, add the exponents, right? Same kind of thing here. For division, obviously you're going to do an opposite process. You're not going to multiply the numbers, of course, because you're dividing. You'll divide the numbers. And remember, when we divide like bases, we subtract the exponents. Well, they're powers of 10, so they're like bases. We subtract the e values. So to multiply, you multiply the numbers, add the e's. To divide, you divide the numbers, you subtract the e's. But, word of caution, it seems so easy. These is very common that the answer is going to be written wrong. So be sure to fix your answers, because very frequently they will not be in correct scientific notation. You're going to need to adjust the decimal a lot more commonly than you would in an addition or subtraction problem. You don't have to adjust it in the problem, you have to adjust it in the answer. Addition and subtraction, you're generally adjusting it to work the problem. Questions on the steps before we try some? All right, let's go and take a look at a few of these together. And just for the fun of it, let's leave the calculators aside here and actually get some practice doing real math here. It's been a little while. So they're not the same e's. Big deal, you can still multiply. In fact, what is the e value of my answer going to be? Let's get the easy part. I know I'm going to get an E8 because I just add the e values. The hard part is the 6.2 times the 5.3. Now, how many decimal places are going to be in this answer? 2. At your seats. Take just a moment to multiply. There at your seats. I know you have calculators, but you know, I gotta do a little practice with real math. Kendall's got it. Downside of sitting front row, I can see your paper. Upside is I can give recognition. Give right answer. Got it? And got it? All right, so again, it wasn't terrible, right? 32.868, but here's the problem. Is this written correctly? Because I have two places in front of the decimal. That's not okay, is it, Kendall? So I've got to move the decimal one more place to the left. And she up and left, so I'm going to have to bump the E up as well. How should I write my final answer here, Michael?
3.286.
And there we go. Questions on that? Does that make sense? So we add the E's and we fix the decimal at the end. On the next one, what's my initial E value going to be in the answer class? E negative 5, because when you add negative 1, negative 4, it gives you negative 5. At your seats, go ahead and multiply the two values together. So we get 19.78 E negative 5, but that's not okay. I got to move the decimal to the left, which means I have to bump the E value up one. She up and left. But what is it? What do I get if I bump this up? Negative 4 when I bump it up, right? So my answer should be what, Audrey?
1.978
Good. Questions on this one? All right, at your seats, tackle that last one. So we should have, check my answer, we get 20.3679. E what, Kendall? Initially.
E2.
Good, because negative 3 and 5 adds to get E2. But we got to fix the answer. Kendall, how are we going to write the final answer?
2.03679 E3.
Good. Now, tomorrow we're going to talk about significant figures, and so we wouldn't actually leave these answers like this, of course. We'd have to adjust and adapt and things like that. But for now, that's how we would leave our answer. Questions on multiplying scientific notation? All right. Again, multiply the numbers together, add the E values together. Let's talk about dividing. We're going to start by dividing the numbers and subtracting the E values. Well, this first one, 8 divided by 4, 2. And we subtract the E values. What is 3 minus 5? Negative 2. Well, that was easy. All right. You can get your calculators out if you need it for this next one. 7.2 divided by 2.4. That's what I said if you need them. Class 3. And when we subtract the E's, be careful. It's 6 minus negative 5. Class 11. Because when you subtract a negative, you add that inverse, right? So it ends up giving us a 3, 11. as our answer here. All right, look at the next one. If you need to, you can use your calculators. 3 divided by 6. .5. And 7 minus 4 when we subtract the e's. E3. But is this written correctly? No. Now, it's okay to have just 2. You could say, I suppose, 2.0. In sig figs, you would. We could say 3 or 3.0. But the point is, we still just had 1 digit before the decimal, right? Here, I don't have a digit before the decimal. I've got to do a rare instance of moving the decimal back to the right. Well, what do I do with the e value? Go down. That was downright good. So when I move this, I'm going to say it's 5e2 as we drop the e value down. Questions on that? Questions on multiplication division of scientific notation? Seem pretty straightforward? Are you going to practice with all of this evening in your homework? But let's press forward just a little bit here. Nope, actually we're ready to give you the homework. So, homework for this evening. Homework for this evening. I thought I had one more thing on the agenda. Helps you look at your notes. Homework, read over pages 9 to 12. Homework, read over pages 9 through 12. On page 17, do problems 3 and 4. On page 17, do problems 3 and 4. And be sure to study over those tables on page 6. The tables you copied last night for homework, study over those as well this evening. So you're reading, you're working problems, and you're studying. Read pages 9 to 12. Study those tables that you copied from page 6. Assuming you copied them correctly, or just study page 6. And page 17, do problems 3 and 4. Take a look at all of this in our next lesson. Have a wonderful rest of your day. When the bell rings, you'll be dismissed.